All right, friends, here we go to our chapter 2 adventure. We are going to start with a little function, domain, and range, something you have seen before, but we're going to dig it up from your brain, try to refresh your memory a little bit. So a relation is just going to be kind of any ordered pair, like X, Y, domain, range, graphs, any pairing at all is going to be considered a relation. And so if you think of relation as like a big pool of space and items, then a function is a special kind of that. So it sort of lives within relations, because what a function does or has is an extra condition. And that condition is that every x in the list or the table or the graph goes to only one y value. So that's what we're going to look at. I always think that a function is like an input-output machine. It has a function. It does a specific thing. Maybe it squares your input. Maybe it adds 5. Whatever it's doing, it has a function. It's like what's being done to the numbers that go in. The numbers that go in are x values. So you can think of them as your input. And then the term we're going to give to those now at this level of math is domain. The function does whatever it's going to do, and then it kicks out a y value. You've done that for years by creating your x, y tables. Plug in the x's, get out the y's. Now we kind of call that y f of x. They're the same thing, meaning the function's value you get when you plug in x. And then that you can think of as the output. And our term for that is going to be the range. So domain and range are simply going to be referring to what did you put in, what did you get out. So listing the x values when you are doing domain, and then listing your y values when you are doing range. If you have trouble remembering, one thing you can kind of think of is alphabetically. X comes before y in the alphabet, and D for domain comes before R for range. So they're alphabetical. So when you go to decide, is something a pairing of numbers, is it a function or not, what you want to make sure is that you stick with this rule. Every x only goes to one y. So when I'm looking at the list of numbers, -2 goes to -3. And then as I go through my coordinates, I never see another -2 as an x value. So -2 never goes to another number, which is when you know it's not a function. -1 goes to 1, and then there's no other -1 going in, coming out as a second number. So really, all I have to do is I look and I say, do I have any repeat x values? If I do have repeat x values, so the answer is yes, I have some, then it's not a function, because it means that you put in a certain x. Let's say I put in a 5, and one time a 2 came out, so I have the point 52, but the next time I put in a 5, maybe a -1 came out. So now I have one x going in and kicking out 2 different y's. So if the answer is no, I don't have any repeat x values, then it is a function. I can't spell. So looking at this one, we have -2, -1, 1, 2, 3. None of the x's repeat. So is this a function? The answer is yes. And then justify your answer. You would just say, no repeat x's, or each x goes to one y. All right, identifying the domain, just think about what that means. It simply just means to tell what the x values are. And so the x values would simply be exactly what you see. It's an eyeball activity. You look at the x values. -2, -1, 1, 2, 3. And then when it says to identify the range is your y values. And so again, I just look through the points, and the y's that I get are -3, +1, 3, -2, and then the last one's +1 again, but I already listed that. So pretend that the function you had takes whatever you plug in, and it takes that times 0, then everything's going to kick out a 0. Put in a 2, get out a 0. Put in a 5, get out a 0. Put in a 7, get out a 0. So in this case, my domain would be 2, 5, and 7, but my range would just be 0 because nobody cares if the y's repeat. Everything can go to the same y. You just can't have repeating x values. So evaluate, we talked about that in chapter 1, and evaluate, the kind of the root word of that is value. So you're going to get a number answer. And so the key to that is just understanding what this question is asking you. It's saying f of 2, in this case, is what? Well, whatever's inside was your input or your x. So think of it like a 2 in front. And then they're asking what y value goes with an input of 2. So I just look up here. I find that when you put in a 2, you get out a -2. So this is going to be a y that goes with the x that's inside the parentheses. So here where I have f of -2, it's asking me if -2 is the x, what is the y? And all I have is this list of points, so I have to look, and I see that according to that, when I put in a -2, it kicks out a -3. So try not to overthink those questions. It's just asking for you to recognize what's inside the parentheses is your input, and what's the answer is going to be your y value. This is a mapping diagram. Don't let it freak you out. It's just an alternative to listing points. These are my x's. These are my y's. That makes this the domain and this the range. And it's asking if it's a function. If you wrote this out, -3 goes to 2. -1 goes to 3. 2 goes to -4, because I think that's negative. And also 4 goes to -4. But that's fine, because to be a function, I check the x's and make sure they don't repeat. And I don't have any repeated inputs. And so there's no repeats, which makes this a function. And my domain would be everything that went in, so everything in that left column. And then my range would be all the things that came out, which would be 2, 3, -4. Now, these both go to the same y, but that's fine. What would be problematic is if you had an x that splits off and goes to 2 different y values, because then you're saying, hey, when you plug in x, you could get out y, but when you plug in x again, you might get out this other y, and that can't happen. So in that case, if you see the arrow splitting from one x to more than one y, you would have to say, no, that is not a function. Looking here, it's just displayed differently, but it's the same concept. These are my x's. If you wanted to write them out as points, they'd look like this. It's just a different way to display the same thing. So you go about deciding if it's a function or not in the exact same way. You look at the x's. And this one is actually not a function, because this right here is a repeat. 1 goes in and comes out as -1, but then 1 goes in and comes out as 2. So that's one x value having 2 y values, and that's not okay. If we had done one of those mapping diagrams, the 1 would have been over here with an arrow going to the -1 and also an arrow going to 2, and then you would have to say, oh, that's not a function because that one x value went to 2 y values. So that's kind of the concept of just understanding input-output. Here, we don't have a function and we don't have numbers to look at, so we have to use something different. And what we use is the vertical line test. And it says, if any vertical line crosses the graph at most one time, then it is a function. So what that means is each of these, like this is the x-axis. So if I draw a line here, that's at x equals 1. This is at x equals 2, x equals 3, and 4, and so on. Same this direction, -1, -2, but these are all x values. So if you were looking for, hey, what's the x value at 1, 2, 3, 4, you'd count up 1, 2, 3, 4, and a half-ish. So there's just one y value. For each of these x's, it only crosses the line one time, and that means that it will pass the vertical line test because you can only cross once, making it a function. Say I had a sideways absolute value graph. Well, there, if I came through with the vertical line, whatever vertical line that is, whatever x value that is, would have two y values because it hit the graph twice. So an example like this fails the vertical line test, and you would have to say, okay, that is not a function. So let's do that aspect. If I went through here and I drew in a bunch of vertical lines, do any of them cross your graph in more than one place? Nope. So that means each of these x's by the lines that I drew only has one y, 1 point on the graph. So this is a yes as well. Down here, if I imagine having a vertical line and just looking to see if there's any place where that vertical line connects, or I should say hits the graph in more than one spot, and the answer is no. All of these just cross in one spot. So because it's going to pass the vertical line test and only hit it one spot at a time, this is a yes as well. One thing I don't love specifically about these examples is they're all yeses. Because even this, it looks kind of crazy town. But I can draw in vertical lines and they're just going to each have kind of one place where it intersects or one y value. So this one again will pass the vertical line test and therefore be a yes. What if I had a graph that was like this? If that was my potential function, I would go, hey, that's actually not a function. Because in this case, this one y that I'm drawing and representing here would have, that one x, vertical line, would have a y here, but also up here. So it hits it twice, meaning it has two y values at that spot, and you can't do that. So let's tackle function value next. I'm not really doing this in order, but I'm trying to do it in an order that makes sense in terms of kind of difficulty, to be honest. Getting rid of my vertical line test lines. Alrighty, so let's take a look at these because this is going to be easier than you think. This is saying x. This is asking y. It's saying when x is 4, what is y? And it's an eyeball activity. You go over here and you go to x equals 1, 2, 3, 4, and you go up 1, 2, 3, 4 and a half because you're kind of right smack dab in the middle between 4 and 5. So this is saying when x is -4, what is y? So I go to -1, 2, 3, 4, and y appears to be a -2. So that part's not terrible. Let's zoom through and do that part. Here, f of 4, meaning what's the function's value when you plug in an x of 1, 2, 3, 4? And the answer is 1, 2, 3. What if you go to -4? So you go -1, 2, 3, 4, and at -4, this graph does not exist. There's no solution or y value that goes with it because it stops. Okay. So then, how about here? F of 4. So when x is 4, what is y? Well, I count 1, 2, 3, 4, and it appears to be at 1, 2, 3. So -3. If I put in a -4, what would I get as a y? So here's -4 for an x, and then I go down 1, 2, 3, 4, 5. So I would get -5 as the y. Okay, so the only thing left to tackle is domain and range, and definitely this can be a brain bender depending on the complexity. So domain, keep in mind, is left to right. So you're going to look to the left and find your x value. You're going to have x in the middle, and then on the right, you're going to have your right side. So this is going to be how far to the right does your graph go. So it might be or equals to, it depends on if it's actually a part of the graph. And then range is the same thinking, except that range doesn't go for x's, it's a y value in the middle. So again, you kind of on a case-by-case basis decide if those are or equals to or not. And then this is going to be the bottom y, and this is going to be the top, because y is in between there. So last thing, when you go up in a graph, that's positive infinity for y, because it's on the y-axis. So when you go down, it's negative infinity for y's. When you go to the right, that's positive infinity for x's. And when you go to the left forever, that's negative infinity for x's. So our domain, we have to look at this. How far does this graph go to the left? Well, it has an arrow. So then that means it's going to go from negative infinity, because it's going as far as it can to the left. You can't actually include infinity, so that's not going to be an or equal to. And then this end actually also goes to the right. Now I get that it's going up, but it is also going to the right. Sorry, I'm boring myself even. All right, range from the bottom to the top. This is going down forever, so it'll go down towards negative infinity. And then y is in the middle because this is range, not domain. And then the right end of this goes up forever. And so that actually is going to be positive infinity. That's not always the case. Here, for domain, this is left to right. So how far to the left is this? -2. Okay. And then that's is included because that's colored in. So that's going to be or equal to. I put x in the middle. And then the other end, which is also colored in, is going to be that or equals to. And that's at 1, 2, 3, 4. So your x's take place between -2 and +4. Now your y's, how low does it go? To right here, which is a y of -1. It actually hits that spot. And then it goes up to here at +2. And so that's going to be what leads me to my range. I can say, okay, well, here is my range from a bottom of -1, which is included, all the way up to a positive value of 2, and then it doesn't go up above that. So this is going to be my range, is from the bottom to the top. This is going to be my domain from the left to right. This one's so tricky because the domain actually has two different things, because if you look at this, there's no actual graph between here. One of these stops right here at an x value of 1, and then the next piece picks up at 1, 2, 3, 4. That's going to be where it picks back up and goes and does its thing. So when I go to do my domain, I need domain for this green piece, which has an arrow, so it goes forever to the left. You cannot include infinity. X is in the middle. And then on the right end, this is taking place at x equals +1, and it is or equal to. So with y, but now I have this other piece. Yes, it ends at 1, but it also picks back up again at 4, which has a closed dot. And then it goes forever to the right, which is going to be infinity. So because you have that break and have to pick up your pencil and move to the right without having any graph, you end up with that split domain. The range goes from the bottom, and even though this looks like a bottom, this actually has an arrow, so it's going to go down farther. And so this is going to go down to negative infinity. Now I know that this part looks weird, but we're just going from the bottom y to the top y. And even though this ends, this other piece keeps going beyond that up to forever. So you just have to kind of look at the pieces and see what makes sense to you. So the range is going to have a y in the middle, and then positive infinity since it's going up. Last one. So, we didn't do this. F of 4 would be at 1, 2, 3, 4. Up 2, it looks like. And this one's saying, hey, what is the y that goes with negative 4? So negative 1, 2, 3, 4, up 1, it looks like. Okay, so the domain here from left to right, well, it's going forever to the left and then forever to the right. It's going to just keep oscillating up and down and up and down and up and down. But it never goes, like it's going to go forever. So it goes to the left forever and to the right forever. The range, however, doesn't go on forever. These arrows are assuming that it's going to continue the same pattern. So it's going to all be contained within here. So the lowest y is at 0 and the highest at 1, 2, 3, 4. So what I know about that is my range is going to go from 0, which is actually included because all these places hit it at 0. And then the y's stay less than or equal to 4 because these maxes are hitting it at 4. And then last little nugget is when is something linear? I always think linear has the root word line. You know that it would make a line if it's mx plus b or ax plus by equals c. So your x is just kind of plain. Nothing weird is happening to it. But when something weird does happen to it, it becomes non-linear. That's not bad. It just means it's not a line. So here the x is squared, so this is not a line. Here the x is on the bottom, so that's going to make it not be a linear equation anymore. So if I graphed it, it would definitely not be a line. This is the square root, absolute value. So with nonlinear functions, something mathematical is happening to the x's, so it's no longer going to graph as a straight line. So in A, this would be a big fat no, it's not linear because the x is squared. In G, it is linear because the x is plane, but it does have a coefficient. And that's what makes it linear. I mean, that's mx plus b form, so you guys know the slope is 5, intercept is 8, and go on from there. All right, that's kind of a lot, but that is the end of 2-1. Enjoy.